Again, we'd like to remind you, if you have any questions, kindly send them in the Q&A tab here in Zoom. We're waiting for your questions, and we'd be glad to receiving them. Moving on, from the University of the Philippines, Diliman, let's hear from Ms. Kate Alyssa Marcelino as they present their study entitled Assessment of Dust Effects on Solar PV Power Production Using Remotely Sensed Data.
Good day, everyone. Today we will present to you our research entitled Assessment of Dust Effects on Solar PV Power Production Using Remotely Sensed Data. Here is our presentation outline. So in this study, the research objectives are first to determine the effects of AOT, particle size, amount of precipitation, and wind speed on the amount of dust deposition. Next, to analyze the dust effects on the solar PV power potential using remote sensing and in-situ observations. Third, to test the significant difference between the amount of dust deposition in UP Diliman, Quezon City, and USEP Davao City. And lastly, to propose a model for effective solar PV power output accounting the dust deposition effects. For the methodology, in situ and satellite-derived observations were used. The processing done was divided into two parts. One is allowed for the acquisition of power degradation rate, and the other is the utilization of multiple linear regression to account the dust deposition estimates. Results will be used to form the effective power model calibration to predict solar PV power output estimates. Shown in this slide are the datasets used. Satellite-derived data were retrieved from Himawari 8-9 and ERA 5, while the in-situ observations were requested from Project SINAG. Now we proceed to the results and discussion. Shown in this slide are equations 8 and 9, which are the resulting dust deposition model for Quezon City and Davao City respectively. The standardized coefficients of the independent variables represent the weight of each parameter to the dust deposition estimate. The results show that the contribution of the parameters vary for the two locations. The table shows that the T-stat is lower than the negative T critical to tail value. Therefore, it can be interpreted that there is indeed a difference between the dust deposition estimates in the two locations of interest, which could be attributed to the varying influence of the factors that affect the dust deposition for the two cities. The dust deposition models were validated by calculating the mean absolute percentage error for Quezon City and Davao City, which are shown in the slide.
Only the Quezon City data were utilized in constructing the power output model. The power degradation rate model for Quezon City is shown, and the negative coefficient shows an inverse relation of the power degradation rate and the dust deposition estimate. It can be inferred that the model does not take into account the majority of the variance of the data given its R value. However, the model could still give a reasonable estimate in population because its significance F is within the threshold values. This shows that the dust deposition still has an effect on the solar PV power output. Integrating the models for power degradation rate and dust deposition, the resulting effective power output model is shown. The effective power output model was validated by plugging in values to the effective solar power output model, and shown in this slide are the results with MAPE with a value of 7.58%. Using equation 10, the power degradation rate for the months of June to December 2023 was forecasted. The prediction assumed that the monthly average of AOT, AE, and wind speed values for the second half of 2023 will have the same trend as that of 2022. The prediction showed a direct relationship between the amount of precipitation and power degradation rate as they increase together. However, this behavior is exhibited only because the values of the other factors aside from precipitation were assumed to be constant. The power output of the clean solar PV module is higher than that of the unclean panel by an average of 4.62%. This indicates that the dust deposition has a negative effect on the efficiency of the panels. To minimize this effect, the weekly cleaning of the solar PV module should be continued. For our conclusion and recommendation, based on the findings, the following conclusions were made. First, for both locations of interest, the AE and wind speed has a positive relationship to dust deposition, while AOT and the amount of precipitation exhibited an inverse relationship. The amount of precipitation and wind speed have more contribution to the dust deposition model than the other factors for Quezon City. As for the Davao City site, wind speed along with the AOT variables have a greater effect on dust deposition. Dust deposition and solar PV power degradation rate has an inverse relationship. There is a significant difference between the amount of dust deposition estimates in the two locations used in the study. And lastly, weekly manual cleaning of solar PV panels will decrease the effects of dust deposition on the power output degradation. From the findings and conclusions, the following recommendations were suggested: to acquire more in situ observations, to lower the temporal resolution to hourly or daily, for future researchers to integrate other important factors affecting dust deposition and also consider other factors affecting power degradation, to do a test between different types of solar PV modules, for future researchers to try manipulating the variables and relate them using nonlinear equations, and for the study to be used for future research regarding the effects of dust deposition on the solar PV power output loss. This ends our presentation. The following are the major references used in the study. That will be all. Thank you.
All right, thank you very much, Miss Kate and Miss Jade, for your presentation.